Welcome, everyone. This is quite a big crowd. Nice. Thanks for showing up. I'm going to talk about GraphQL today. It's kind of a passion for my own side project. A few years ago, I came across this technology and fell in love with it. And that time, we also did a little bit of research on how would we implement this in the project back then I was working on. So this whole presentation is based on that. So we did an extensive research on which framework would we use. We had a Spring Boot project, not one. There are multiple microservices. And for one of the microservices, we wanted to implement GraphQL. And we did a research on different frameworks that was available within Spring Boot ecosystem. And I'm going to try to give you that knowledge that we gained in that exercise. Hopefully, you'll enjoy it. Who am I? My name is Soham. I work for Microsoft as an Azure architect, even though I'm not going to talk about anything related to Microsoft today. This is totally based on open source and Spring Boot. I try to play football whenever I can. I try to speak and blog whenever I can, even though the last 2 years have been a bit tough on the blogging side. But I'm going to pick that up as soon as possible. You can find me on any of the social channels available. And I come from, that's not Taj Mahal, by the way, if you know. That's Victoria Memorial. That's where I am from. That's Kolkata in India. And I live in a very beautiful city in Netherlands called Utrecht. So that's a little bit about myself. What we're going to talk about? We're going to talk about what GraphQL is. How many of you are aware of GraphQL? Super cool. I can skip that part, right? I'm going to do a very small explanation in that case. And then I'm going to show you what are the different frameworks we have. Mind you, there are more frameworks available in Spring Boot ecosystem, even though in the Java ecosystem as well. I just picked up 4 of them. That doesn't mean there are much more options. And then I'm going to do a little bit comparison about different aspects of the GraphQL based on those frameworks. So, as I was saying, long time ago, we had a microservice which was querying a very simple data structure. We had providers, we had services. The providers will provide multiple services to the citizens. We were building this for government, and there were a lot of entities within the government provides a lot of services to the citizens of Netherlands. And we had a website which actually shows all those so that you can select which services you want to choose for which government entity. So as anyone starts, we created a REST endpoint on top of the data structure. So there were different pages in that application where we wanted to only show services, where we wanted to only show providers, where we wanted to show provider along with their services. We wanted to show services along with their providers. And you know what? The requirements goes on and on and on and on. And then we ended up, seriously speaking, with 10 endpoints on that microservices. And it also changed in a while a bit because we wanted to show some information when you are not logged in, just landed on the home page. We wanted to show some information which, when you log in with your credentials, then there are some information would be shown. Yes, we could have done that with authentication and authorization on the Spring Boot, but like any other project goes with requirements, goals, and deadlines, we made separate endpoints. At some point of time, it became a little bit difficult for us to identify what I'm going to expose and which requirement is going to map to which endpoint. Since this was a hierarchical data structure, it became a very valid use case for GraphQL. So as you can understand, we tried to change this, and we succeeded. And that's the story I'm going to tell you. So a little bit about GraphQL. GraphQL is actually an aggregation. It was released by Facebook in 2015. And the whole idea behind GraphQL was your existing infra will remain same. You are not going to change that, and that's all the library is going to do. So if you have a REST endpoint already developed, all your repositories, all your classes that are calling the backend APIs, those are not going to change. you're going to just put a wrapper around it and expose that as a GraphQL. So it becomes an extra service rather than, or like a plugin rather than a complete code rewrite. It has nothing to do with GraphDB, although you can create GraphQL on top of GraphDB, but this has nothing to do with it. And it's also not replacement of REST. So you have to be very careful about that as well, because every new shiny technology comes new shiny problems. I'm going to touch upon a bit as well, what are those as. And it's also not going to solve your API design. Like our API design was bad. We could have done it in a different way. And it's not going to solve introducing GraphQL as well. So very careful about those things. Yeah, every technology has its pros and cons. As you all, most of you are aware what GraphQL is, even though this is quite a repetitive, I'm going to quickly go over for everybody's sake. GraphQL starts with a schema. Similarly, like OpenAPI definitions, you guys are aware of OpenAPI definitions, right? Swagger, yeah. So it's very similar to that. So where do you define what kind of queries you can do and what kind of mutations you can do? So it's same as REST APIs, where you can do CRUD operation, post and put. In GraphQL technology, we call it mutations. And when you do a get in GraphQL, we call it a query. So you query some data or you change some data. And in that schema, you define also what are your entities. Just like in OpenAPI, you also define your entities and how your response or request will look like. Here also you define it. But it's much more concise. So you can actually one-on-one map it to your JP entity structure as well. So for this example, we had providers and services, and every provider has an array of services, and a service also has a link to a provider. So similar to your data structure mapped to there. Then you do a query, and when you're doing a query, you define what you want to get. That's the most powerful part of GraphQL. So in REST, even though you don't want half of the information, maybe you will still get it in your client. Doesn't matter whether it's an HTML page or your Java client or any other client. In GraphQL, you can control that. You only retrieve the data you want. So even though my query defines that services by ID will return a service object, you can still say, I only want name and description, nothing else. I don't want provider to be retrieved on this page or in this query. And the results will be shown like this. Let me show you a few. Where is my? There. So for example, like this, if I just want name and description, I get name and description. And your backend, which I'm going to explain a little bit later, you can control that retrieval of provider will be skipped for these kind of queries. And that makes your backend also a little bit more performant. So when you are not querying something, you're not retrieving something. Less load for your backend, less load for your network. You can do all sorts of custom stuff as well. And I am going to show you in the GraphQL interface. This is also something which comes with all the frameworks. Some of them you need to explicitly switch it on. Some of them it is automatically switched on, and you have to switch it off. So GraphQL is a graphical interface provided by GraphQL frameworks to run your queries on the browser. So when you are testing something and you don't want it Postman or something else, then you can test it here pretty easily. And it gives you autocomplete. So for example, if I want to do a query of provider by ID, and I'm going to do an ID of 4, for example, and I want to name only, and voila, I have the data. You can also do a little bit of magic. Let's say you have in your page a left section and a right section. And in both the sections shows some provider properties. And it happened to be the case that both the sections will show you name and description of the provider that you're fetching. So for example, I can actually say, fetch me fields, and the fields are my provider with name and description. Is it the 4? Let me do 1. What I just did, executed 2 queries with 1 HTTP call. That's also another powerful part of GraphQL. In REST, you might have to do this in 2 calls. So you minimize the load on your network. And in GraphQL, you can define dynamic fields that you're querying out. So the fields that I mentioned there, that's basically a name of a variable. You can put XXY or whatever you want, and you define that variable actually maps to provider, which is a name and description. So for example, if you have a big page showing different similar information in different sections of the page, and you just want to do 1 query, this is your lifesaver. You saw it a bit, but I'm going to quickly touch upon this as well. I want you to concentrate on the status 200. Even though my backend throw an exception, it's a catched exception, you'll still get a 200 back. There is a divided community on this because exception handling in REST is very much typed, and in GraphQL it is not. But I quite like this feature because you do not have a try-catch block or something called a controller exception handler in Spring Boot. You get a response back, and response has either a data part, which gives you the results back, or has an error back, which also gives you the information about what happened in the backend, if there is nothing exist. So I threw this exception for if the provider ID doesn't found from the backend, but it's a thrown exception from the backend, but GraphQL resolves it as a 200. So this is also quite a powerful feature, according to me, on the GraphQL side. So who is using it? Quite a lot of people, actually. If you go to that landscape GraphQL org, I couldn't fit everything in this slide as well. But to give you an idea, the community is quite big. In compared to REST, not so much maybe, but they are catching up. So what are the 4 biggest characteristics of GraphQL? You have to remember this is a hierarchical, it works on a hierarchical data, and it aggregates from different data sources. So if you have a use case like that, GraphQL might be a good solution for it. It's strongly typed. So you define your entities. When you query, you define what you want to get. And if that doesn't resolve, you get an error back. So there is no guessing on that part. It's strongly typed. The validation and the type check are out of the box. So you don't need to write anything whether your request has some kind of weird characters in it. It is done by the framework itself. The last point is also kind of divided in the community. Since it's a entity which you define when you're querying or doing a mutation on a GraphQL object, you can deprecate or add stuff on the entity level. So the GraphQL evolution of your response structure evolve without API versioning. It helps sometimes. It also doesn't help sometimes because if your clients are not aware of what is added, what is removed, you might have a problem. So it comes a little bit in a gray area when you're doing federated queries with GraphQL. I already talked about this a bit. So you can define fragments, you can define aliases, you can send arguments as a typed object. And you can also define interfaces when you're defining your schema. So interfaces is a bit similar to the Java one, but in there, it's basically define the parent object, which really you can use on your query itself. But when you're defining a child from that interface, you really need to define everything, like the screenshot shows. It supports integer, string, Boolean, ID, and float. You can also create custom objects as well, custom scalar types if you want. GraphQL, which is the parent project for all the frameworks which I'm going to talk about, defines how to do that. But as I was saying, not everything is cloud number 9. There are problems. N+1, how many of you are aware of N+1 problem? Okay, some of you. I'm going to explain a bit later on as well, but it's related to the queries gets executed for your parent query to the child ones. There is a problem with caching. Spring GraphQL and Netflix GraphQL framework provides a little bit of caching, but it literally depends on you how you cache your data on the backend queries rather than on the GraphQL layer. The community presence is also not that huge as you imagine for REST or SOAP or any other way of making API available. And pagination is also something of a pain because you need to define your entities in such a way that the pagination works. So the framework doesn't provide support for it. So you need to really do it yourself. OK. My whole comparison is based on a very basic Spring Boot application, which is connecting to a database which has a hierarchical data structure. I have a JP repository querying via Hibernate. I have a service layer, which is basically calling the repository. And I have a controller, which is exposing number of REST endpoints. So keeping in mind this, how would I implement this in different frameworks? OK. First framework is GraphQL Java. Let me remind you, all those frameworks that I'm going to talk about are based on the base Java GraphQL framework. And every framework did it in a bit different way and tried to solve a different problem which they saw important for the GraphQL community. This is the oldest one. But this project has been archived in support for Spring GraphQL. Why am I telling you this? Because it's important for you to know how the journey actually started. So when you define a GraphQL API based on that framework, you need to define how to read the GraphQL schema. You need to define how to do a data registry. You need to define how to do a data loader. You need to define how to do a data fetcher, and how all of this comes together in the runtime wiring. All these buzzwords I'm also going to explain in a bit. So hang in there. But importantly, notice I have only replaced the controller. The rest of the part remains the same. As I said in the beginning, your infra or your backend code is not going to change at all. This is going to just add a plugin type of a scenario on top of your existing code. Second one is Java Kickstart. This is also quite updated. The last update went in on December. And this update is actually for the Spring Boot 3. The previous versions you can use for 2.7.x. They are also quite active. How to use it? You need to have two dependencies. Actually, the first one is more than enough. But if you actually have different scalar types or different data types which you are reading from the schema, then you might need a few more dependencies. The community is active there. They have a very good documentation page. The GitHub is very much updated, so you can check it out. But how does it look like? See, I was trying to tell a story. The first one had a lot of blocks at the first time. So Java Kickstart project, they thought, let me minimize that. So there were a lot of boilerplate text. There were a lot of boilerplate code. So they made it a little bit simpler for us. So they made resolvers. The resolver is basically an implementation of an interface, which will provide you the implementation of your query and the mutations. I'm going to show you also code in a bit. So then you can put these images in a bit of a picture. And it has a data registry and a servlet which basically serve the GraphQL queries and mutation on top of it. So it's also minimized the first one which was implemented for GraphQL. Again, service, repository, database, same. Still a plugin. Third one is from Netflix. This was released around about 3 years ago, if I'm not wrong. And the last update went in on April, so last month. Quite active. The 6.x versions are for Spring Boot 3, and before 6 are for 2.7x. And it only requires one dependency to be added in your Spring Boot project, and then you are ready to go. Again, a bit more simplification than the previous implementation. They introduced annotation-driven implementation, just like, yeah, we are all quite familiar when we implement Spring Boot application. So they introduced two types of annotation. If you have a data loader, you use the DGS data loader, and you implement what you want to do. And if you have a data fetcher, you implement DGS data, and then implement your structure. Again, repeating myself, I know, service, JPA, database remains the same. Still have a plugin. Last but not least, the Spring GraphQL, Spring for GraphQL. I don't know why they chose the name, but OK, I found it funny. So they came out last year. The last update is for also Spring Boot 3. The 1.0.0 was 2.7x. Everything beyond 1.0.0, am I saying this right? No, actually, before 1.0.0, everything was for 2.7x. And from 1.0.0, it's for Spring Boot 3. You need one dependency, and that's what it is. They thought of the implementation in a different way. So they wanted to have the way we implement REST interfaces for Spring Boot. So they still have a controller where you actually expose your GraphQL endpoint. But then they have supporting interfaces, which actually helps you implementing the schema mapping, the mutation mapping, and the batch loader. The batch loader is basically for the data loading part when it comes to n+1 problem. But again, the rest remains the same. So every framework that I just talked about, all four, they wanted to have something which nobody needs to change their backend code. And yeah, everybody tried to look at the problem in a different way. When it started, it was a lot of boilerplate code. Everybody looked at it and picked it up different problems to solve for different frameworks. So a little bit of comparison, and this is where I'm going to go inside what data fetcher is, data loader is, what is n+1, and I'm going to show you some code as well. So what is a data fetcher? In a very simple words, the piece of code that is getting your data back from the backend. Just a reminder, this is not the relational data. So if you have provider, which have a services linked, or a service which has a provider linked to it as a foreign key, it is not for retrieving the provider, but only the service. So the related entities being loaded by another component. Why? That I'll come to it as well. So how do you do it in GraphQL Java? You have a component, and you define your data fetcher, which basically calls a repository method to get all the data back. Pretty much simple. How do you do it in Kickstart? As I was saying, you get a specific interface. If it is a query, you do a query resolver. If you have a mutation, you do a mutation resolver. The catch is when you define in your schema that I want services by ID, it maps the name of the method with that query or the mutation which is defined in the schema. So that's basically their way of doing it. DGS, as I said, you need to define a DGS data. The class will be annotated with DGS component. And in that annotation of DGS data, you define what type of operation is this, and where is this mapped to. If your name of the method remains the same, you don't need to define your schema, what you define in your schema. So the name services by ID, I could have omitted it out. Spring for GraphQL, they also followed the annotation-driven approach, but here your class is annotated with a controller because they wanted to have the similar approach as the rest. But you do a schema mapping where you say what is the type and where it is mapping to. So pretty much similar as DGS data. Now, n+1. What is n+1? So let's say I have a service entity which is a foreign key to provider. Pretty much normal that we see all the day. And then if you do a service repository find by ID, if you are not handling this properly, not only it'll fire a query which selects the service, but for every service, it'll also fire a query to retrieve a provider. Hence the name n+1. So if you have n number of services there, you have n number of queries that are being fired for provider and one query for all the services. And if there are a lot of ways to solve this in Hibernate, in any other framework where you are actually JOQ, where you can actually retrieve the data from the backend. But if you're not careful enough, you actually bombard your backend with a lot of queries, which is not really nice. As I said, it's quite easier to manage it from the framework that you're using to retrieve the data from the database. But in GraphQL, you don't map your foreign keys in the entity like we do in a normal JPA. You map the ID part, and that you resolve on the runtime. So if you do this, and you depend on your backend, it will anyway fire the n+1 queries. And that's going to be a very big challenge. And to solve that, GraphQL has data loaders. So data loader is basically, there are two types of data loaders in every framework. One is a batch, one is a map. So what it does is it creates a completable future, and it will fire all the queries, all the provider that it needs to retrieve at the end of retrieving all the services. So rather than having n+1, it'll do two queries, 1+1. So one for all the services and one for getting all the providers. And to map the providers that are retrieved to the services that was retrieved previously, it uses two types of loader. One is a batch, one is a map. The map is much more structured because every service ID is mapped to a provider. The batch basically do a one-on-one mapping. So if my first service is this, and my second query, the first provider is this, I'm going to map that. So sometimes you can get an overlap. So if you do not have too much data on the backend, it is easier to use batch, but advisable approach is to use a map. In my examples, the Spring for GraphQL, I used a map. For the rest, I've used a batch, just so you know. So just to give a different view. So in the GraphQL Java, you do it like this. You need to define a computable future, and then you need to register that. So when GraphQL is resolving the mapping from services to provider, it uses this to fire those queries at the end. In Java Kickstart, it's a bit bigger. Same concept. You still have a completable future, but the way you map it is a bit different in here. And it, as I said, it has a bigger implementation than the previous one. The DGS is quite straightforward. So still you define a completable future, and then you map that completable future to the property of the entity. So in this case, I am saying if my entity is service and the field is provider, you need to use the data loader that I've defined there. It's quite intuitive, so the readability is much more higher in this. The similar structure is also for the Spring for GraphQL. You need to register it, and at the time of initialization of the application, it registers it as a data loader in memory. Error handling. As I said, everything is 200. you will never get anything else. Yeah, 404 can be. But if there is a exception, your status, HTTP status is always 200. And the way GraphQL define it is, you get an error back with an error object where all the information are there. And every framework provides a way to customize that information, to give the client, whoever is calling it, a better insight on what happened at the back end when it went wrong. So in the GraphQL Java, you need to basically implement an interface, and then you define different kind of errors when it occurs. In Kickstart, you can do two ways. The Spring way is the exception handler. So you can enable a property, and then you can define your exception handler the way you do it in a controller advice. Or you can implement the GraphQL error handler and manage it there. In DGS, you implement an interface and override a method to manage these exceptions. It's not really intuitive, but you need to have a lot of blocks of code to define if exception A happens, do this, exception B happens, do that. A lot of code, but yeah, that's how they want to implement it. In Spring for GraphQL, also pretty similar approach, but the way you handle the exception becomes a bit less. So in my thinking, they saw how DGS did it, and they simplified the approach without changing it too much. Now that we talked about the server-side implementation, there is also client. I'm going to talk about how you implement a client in Java when there is a Java client actually consuming a GraphQL API. In GraphQL Java, there is no defined way. So you have to use different types of way to invoke an API and parse that object. Do I show it now? Oh, yeah, let me show it. Why not? This client. This, I'm going to stop. Yeah. So if you want to resolve this particular GraphQL schema where you have a provider and a services and depend on just calling an API and parsing the JSON which you're getting back, you really need to go through and create the whole structure that are defined or returned by that entity. So if you want to resolve the JSON and use it in a very type-defined way, then there's a lot of code needs to be done. And that's quite same for most of the frameworks. So for example, it's always have a data, and a provider data will have a provider by ID, and the provider by ID will have, it's basically a provider which has all the things. Same goes for error. You have extensions, you have GraphQL error, you have locations, and you need to define all this classes and objects yourself, and when you're parsing it, it gives you back the data that you want. So as I was saying, there's no defined way. You can call it as a simple API call and retrieve it and parse it with your own object structure. Same goes for Java Kickstart. Even though they give you a library to call it, it's basically minimizing the lines of code required to invoke that API, nothing else. So at the underline, it's using reactive streams, to be honest. DGS is the best in this class because they provide a Gradle plugin, and the community also have created a Maven plugin. You can generate all these objects by yourself. So your code base remains pretty much smaller, and then you can just use that to query it. So for example, if I check out this, you'll see my code base became very small. And basically, it generated all the client that I need to retrieve or call the APIs and all the types that are defined in the schema. So at compile time, it sees the schema, it generates the code for you. Only thing you need to do is how to invoke that API. All this code is in GitHub. I'm going to provide the QR code at the end, so you can play around and take a look. So yeah, it gives you the Maven or Gradle plugin, and the only thing you need to do is define how to retrieve it. Springboot GraphQL doesn't have that option, but yeah, it's a Maven plugin, so it doesn't really matter. You can use it for this framework as well. It's only generates your client. You can use the types, basically, and call the object. So testing and code generation, I touched upon a bit. There is no defined way for GraphQL Java or Kickstart. In DGS, you can generate the entities on a type-safe way, and when you're writing unit test or integration test, you can use those types to check whether something is being retrieved or not. There is no code generation for GraphQL, but you have an auto-configure GraphQL annotation, which helps you to write unit test in a very intuitive way. And responses you can map to a custom object. That can also be possible. And as I said, the DGS plugin is basically a plugin, so you can also use in other frameworks as well. So, final words. GraphQL Java is there for a long time. Even though it's archived, the base package, which is used by all the frameworks, are still there. But yeah, this is archived, so there's no point in talking about it. Kickstart is there for a long, long time. It's quite mature. It supports Spring Boot 3 as well. Only difference is, yeah, a bit of more coding than DGS and Spring GraphQL. DGS, the biggest point of this is not based on reactive streams. That's the difference with the Spring GraphQL version. So when you are calling, so for an n plus n situation, when you're calling different related entities, it's going to be called one by one, unless you implement something custom to make that happen reactively. But the biggest plus of this framework is it has very good support for client side. So if you have a GraphQL client, which is calling GraphQL APIs, you can use that for code generation and minimizing your data. Springboot GraphQL, I'm not sure about it. It's, by the way, it's personal opinion. So I have to make that very clear. It's been a year. It is based on the same approach as DGS, the annotation driven. So I'm really not sure how big the community also is, because the Stack Overflow is not overflowing with questions from this. So be careful about it. But Spring is behind this, so they are. So that's the biggest plus point, I think, on this. No code generation, but again, plugin from DGS can be very well used that in the other framework. Code is here, slide is there, and I have 12 minutes left. If you have questions. Thank you. Yeah, there, doesn't matter.
I was going to ask how much support is there on the front-end side for this?
There are support for front-end side. Apollo has their own library to generate front-end code when you want to. But this was more on the Spring Boot side, if you have client on Spring Boot side. So if you have a Java front-end, you can use these plugins anyway.
No, I was wondering if I decide to do this on the back end, will the front end guys swear at me, or will it be easy to
I think
integrate?
it'll make their life a bit easier. At least that's my opinion, because you do not need to maintain multiple calls for similar results. So you define, as I explained at the very beginning, you can also have same query running for once, a multiple query running once, and you get back the data. So it's going to minimize your network load as well. It's going to minimize the number of calls you're going to do at the back end. So that's. But yeah, it really depends.
Hi. Do you use GraphQL for back-end APIs, so back-end to back-end systems, or do you only ever use it for front-end to back-end
No,
systems?
this for backend. So as I said, there was a hierarchical data structure which had a lot of REST APIs. So we converted that to a GraphQL endpoint.
Okay.
So there was this service by ID and service calls,
Yeah.
but there was no, like, where do you define that you only need the name and description? Like, since you needed just two things, name and description, but where was that defined in the code?
It's not defined in the code. It's being handled by the GraphQL framework at the very front. So when you say only give me name, the GraphQL resolver will resolve the query and fire a backend query for services and give you back only the name. So if you have a database query, you are still getting all the properties of services, but you're only sending back to the client the name.
Okay, so there is a network call though,
That-
from your backend to the database.
Yeah, yeah, so, true. Or any API if you're calling. Yeah.
Thanks for a wonderful presentation. My question is it recommended to use GraphQL, SQL in the case of routers and handlers, Springboot reactive programming?
It really doesn't depend on that. It depends on what you are fetching from backend. So it's an aggregator. So if you are fetching data from different sources and aggregate and send it back to the client, then GraphQL is maybe your solution. But it doesn't really matter whether you're doing reactive streams or not, to be honest.
Thank you.
In the example of batch mapping,
Yeah.
if you have like a collection of 2,000 items that you want to map to another collection of 2,000 items or whatever, you have to load each one in memory to do that mapping, correct?
Yeah, yeah.
So that can be like quite expensive. So how do you recommend you deal with that kind of situation?
The map, the batch loader or map loader, both of them will do that in the memory, but the framework handles that for you. So yeah, it's a load when you map it, but it's your in-memory load. And it's if your data grows, then yeah, you need to handle it in a similar way how you handle it for REST. So there is no real magic wand for that, to be honest.
Fine, okay.
Does GraphQL support more efficient serialization formats than JSON, for instance, Avro?
And I don't know, to be honest. Afro, I mean, for Kafka serialization.
Avro or protobufs or, binary communication, I suppose. Isn't it?
I wouldn't know. I'm sorry. I might have to check that out.
My question was on pagination. So you mentioned pagination was a problem, but if you've got a lot of data to return, then are there ways around that?
There are ways around it. So you define your schema that way. So let's say, for example, wow. Is my schema open? No. So let's say you have the schema defined as provider ID string. So these are all properties for the entity itself. So in there, you also need to define offset and a page. Or maybe number of entities that you want to retrieve. And then you have to handle that and resolve that in your code yourself. So none of the framework provides support for that.
That makes sense. Thank you.
Yeah.
Thank you for your clarification of GraphQL. I have the question: do you prefer the schema-first approach, or
I prefer the schema-first approach. Yes. Yes.
Could you explain why?
Because then you define your. It's the same argument as when you create REST APIs. So if you define your definition first, then everything follows through. So the plugin which DGS provide, which I quite love, you can use to generate your clients and entities. You can also use to generate your backend entities as well, if you choose to. And you can also share the schema definition with other teams which might be consuming this application. So definitely I prefer schema-first approach because of, then everything works parallel. So you can go on development, and the testing team can create the test cases, and the consumers can start writing code to consume that API. So yeah, for that reason.
How seamless can GraphQL integrate with something like Spring Gateway or Azure API-M?
Yeah, it can, definitely. It's just an API endpoint. So if you see, this is just an URL. So put anything which you want to put in front of it. An API gateway, also Spring API gateway, or anything which is from a cloud provider, basically. So it's just like a regular endpoint. The way you send request and receive response is a little bit different. That's it. Yeah. Okay. Last question.
Thank you. Is there any way to change the status because GraphQL always returning back 200? No?
No. Let me put it this way. I don't think it is. But be my guest. I would also love to know. But that's one of the powerful, as I said, part of GraphQL. So yeah, I would not. It's my personal choice.
Thank you.
Thanks for the talk again. How can you explain again how, like, changing a schema in your further releases will impact the clients, and how to align that?
So for example, if you, let's say, remove the description or rename it, you deprecate a field. So you deprecate a field. So you put an annotation in GraphQL. There is a way to deprecate a field. So when you deprecate it and you release a new schema, when they consume it, they already have the update. If that's the best approach. If they are not consuming your new schema, they will not get back the field they're asking for. So it'll omit. So for example, if you remove description and the client is still trying to retrieve name and description, they will only get name back.
Thank you.
Thank you for listening. I hope I taught you something new or motivated to learn something new. And yeah, thanks a lot. Thank you.